Hi everybody, welcome back to another video. This one is about simplifying higher order radicals, and well, I want to begin by just going over some general rules with you. So here we go. With higher order radicals, the basic ideas are similar to ordinary radicals involving square roots. And just to give you an idea, if we look over here, if we have in the first one we have the square root of 4, which can also be read as radical 4. The square root of 4 is 2, and the reason for that is because if you were to square the 2, you would get 2 times 2, which would make a 4. Okay. With a cube root, the cube root of 8 is equal to 2, but the reason is a little different, but it's also a little the same. So the reason is because 2 to the third power, if you were to cube a 2, you would get 2 times 2 times 2, so 3 2's this time, which would then make the 8, which is the radicand inside. With a fourth root of 16, the answer is still a 2, but the reason is because if you were to put 2 to the fourth power, you would have 4 2's, in other words, 2 times 2 times 2 times 2, and that would give you the 16, which is the radicand. Okay, so in each of these cases, what you should notice is that the radical you're dealing with, the order of that radical, has a direct connection and correlation actually with the power on the answer, which gives you back the radicand. So in this case, again, you have a 2 here, you have a 2 there, a 3 there as your order, a 3 as a power, a 4 as your order, a 4 as your power. Okay, but there are some other things to note as well. There are radical canceling powers. Everything in math has to do with opposites. So if you can do something, you should also be able to undo it. So it's the same with radicals. So a square root can be undone by a square. In fact, they share the same word, square, square root. In other words, a radical with an order of 2 can be eliminated with an exponent of 2 in the radicand. Okay, and then you would just get the base of that radicand itself, which is just the a. In the case of a cube root, it works pretty much the same way, but in order to cancel a cube root, you would need to have a power of 3, because this is the order of your radical. This is the power required. Okay, for a fourth root, it would be the same thing. A fourth root requires a power of 4 on the radicand in order to eliminate. And in each case, when they eliminate each other, the exponent and the order, then what you would get is just the base of the radicand by itself with a power of 1. And actually, I'll put that in. So your power actually is just a power of 1. That's what you have left over. Okay, there are also negative radicands, and when it comes to an even number inside the radical, so if you have an even radicand, it's not possible to get an answer for that if your order is an even number. If it's an odd number, though, it's okay. And just to give you an example of that, I'll put one over here. As an example, if you were to try to do the square root of -4, and you plug that into a calculator, it would say, that's wrong, I can't do that. It would give you an error message. This is undefined, and the reason is because no number squared will ever make a negative number. So if you were to take 2 squared, you would get a +4, which is not your radicand. If you take a -2 and you square it, you still get a +4, which is again not your radicand. So when you have an even number, it doesn't work. But when it's an odd number, it's a little different. So if you were to have, let's say, the cube root of a -8, well, in this case, you do have an answer because you're trying to think of a number that you'd be able to cube and still get a negative number from that. And it is possible when you're multiplying 3 numbers to get a negative result because of that third number somewhere in there being a negative. So In this case, my answer would be a negative 2. And the reason is because if you were to cube a negative 2, like this, what you would get is you would get negative 2 times another negative 2. And if you break this down carefully, what you should see is that these two negative 2's produce a 4, but when you introduce that last negative 2, multiply times negative 2, what you get is the negative 8, and that is your radicand over there. So it is possible to have a negative radicand when you have a high order of an odd number. Okay, so just bear that in mind. Okay, so with that, let's go ahead and generalize. Again, powers canceling radicals, higher order radicals, if your power inside on the radicand is the same as the order of the radical, you're going to get that base by itself. Okay, it's going to come out. All right, so with all these things in mind, and I know it is quite a bit to think about, but with these things in mind, let's go ahead and jump into some examples. So many rules for simplifying square roots also apply to simplifying higher radicals. So let's take a look at example 1 over here. In example 1, we have the cube root of negative 16x to the 5th power. As a general rule, it's a good idea to split whatever you see inside the radical so that you can handle each part independently. So what I'm going to do is just that. I'm going to split it, and I'm going to write the cube root of negative 16. Keep in mind we have a cube root, that's an odd number there, so it's okay for that negative to be there, times the cube root of x to the 5th power. All right, so what we want to do is we want to think about, first think to ourselves, if there's a number that you can multiply to itself 3 times to produce a negative 16. The answer is no, there is no such number. What we do instead, when you don't have a perfect cube root here, is you split the number further until you can produce something of an answer, of a perfect cube root. So this would be the cube root of, let me see, what two numbers multiply to make negative 16? Oh, well, negative 8 and a positive 2. So I have the cube root of each of those numbers. For the x to the 5th power, I would have to split this so that what I have is as many cubes inside as I can. Remember, when your power inside matches the order of the radical outside, then they eliminate each other and you get what's inside. It comes out free. And that's what we want. We want to see how many of those, how many x's we can free from this inside. But we need to pull out as many x to the powers of 3 as we can. And so here we go. So this is going to be, well, let's see, x to the power of 5. How many 3's go into a 5? Well, I know that 1 3 goes into a 5, and I have 2 left over. If you remember the laws of exponents, if you test it out, this 3 over here and that 2 together, if you were to add them up, you would get 5. And that's how I know that it's safe to split it up the way I did. Okay? All right, so what's going to happen next is I'm going to do some canceling. I'm going to do some simplifying. Now, the cube root of 8 is a perfect cube root. And because the reason I know that is because negative 2 cubed produces a negative 8. So this will be just negative 2 over here. Okay? Over here, this 2 is going to stay stuck inside. And the reason is because there is no number that you can cube that will give you a 2. There's no number you can multiply to itself 3 times that will give you a 2. So this stays inside. Over here, these two are identical, so they eliminate. And what I'm going to get is this x drops down for free, and I get an x on the outside. Okay? But this power of 2 inside does not match the order of the radical. And so it's not strong enough. It doesn't have enough power to cancel that cube root. Therefore, that stays locked inside as well. But we have to drop everything down. So here I have the same thing I had before. Okay? Cube root of x squared. Now, to finish up, everything that is outside needs to be multiplied together and sent to the front. So what I have that is outside is this and this. They will multiply together and appear at the front. So it's negative 2x. Everything that is not outside gets put together as well, but they get put together under the same radical. So that means I'm talking about the 2 here and the x squared there. They get put together, but under 1 cube root like this. So it's 2x squared. And that is our answer. Okay. All right, example number 2. Let's take a look over here. This is a bit heavier just because of the size of that number. But let's jump right in. So the first thing that I'm going to do is pink please, is split this up. So this gets divided into the fourth root of, oh, that's just terrible. Let me do that again. The fourth root of 243 times the fourth root of b to the 6th power. Okay? Notice that I have a fourth root this time, not a third root. So this is an even higher order than the one before this example. Now, in this example, because it's an order of 4, I want to think of a number that can multiply to itself 4 times. So I need 4 of a kind here. That's what I'm going for. For 243, the numbers that I can think of are the following. The fourth root of, this would be 3 times the fourth root of 81. So 3 times 81 is 243. My focus right now is just getting 2 numbers that multiply to make that 243, and I just did that. Over here, I want to split this so that what I get is as many powers of 4 out of this power of 6 as possible. Okay? So how many 4s go into a 6? Well, let's see. 1 4 goes into a 6, and what I have left over is a 2. Okay? Again, 4 plus 2 is 6. That's how I know that this is going well. Now, these two will eliminate each other because they are identical, and what I get from that is the b comes out by itself, like that. This power of 2 is not big enough to cancel out this higher order, which is a 4. So this stays locked inside, and that b squared is not going anywhere. So fourth root of b squared. Okay, that part is pretty much done with the variables. This 3 inside, again, is going to stay stuck in there. Whoops. Because there is no number that you can multiply to itself 4 times that will give you a 3. So my focus right now is this 81 here, splitting that 81. I'm going to split the 81 into the following. I know that 9 times 9 is 81. Okay, so I have 9 times 9. But I also know that each of these 9s is made up of a 3 times another 3. So what I have right now is 3 times 3 times 3 times 3. Okay, those are from the two 9s. That b comes down, this comes down, and now because I have 4 of a kind over here, I have 4 of a kind. That's a good thing. 4 of a kind means the following. I basically have this. What this is saying is I have this. That's what I have. And because they are identical, what that means is that these will cancel out, and I get just the 3 by itself. So I have fourth root of 3 times just a 3 times just a b times the fourth root of b squared. And everything that is outside gets put together and swings to the front. Everything that is inside stays inside. So what I have that's going to go to the front are these two. What goes inside are these two. And my answer is 3b times the fourth root of 3b squared. And with that, we are at the end. So I hope this video helped you out. I know that there's a lot going on here. There are many steps to keep track of, but just keep in mind a couple of pointers. When you're doing these things, go for perfect radicals and take those out. Please stop by, leave a comment, and as